Welcome to next lecture of hybridization and aromaticity. So in this lecture we will discuss some previous year questions. First of JEE Main and NEET. After that some questions of IIT JAM. And at the end some questions are from CSIR, UGC NET and GATE. So let's start. Question number 1 of this lecture. In the following compound, compounds, the favorable sites for protonation. Favorable sites for protonation is or are. The compound given is like this. This compound is given. So here there are total 5 nitrogen atoms. Each nitrogen atom is marked as number 1. This is number 2. This is number 3. This is number 4, and this is number 5. Options are option A 1. Option B 2, 3 and 4. Option C is 1 and 4, and option D is 1 and 5. So this is the question. So in this question there are 5 nitrogen atoms, and we have to find which nitrogen undergo protonation easily. Favorable site for protonation. So by using aromaticity you will see one by one on which nitrogen atom the lone pair of electrons are easily available for protonation. If the lone pair of electron and nitrogen get involved in resonance, it means that lone pair of electron is not easily available. So we will just apply the concept of hybridization and try to find which lone pair of electron or nitrogen atom is not involved in resonance, or you can say which lone pair of electron or nitrogen atom is present in sp2 hybridized orbital. In other words, we can say like this. So come to first. Here the nitrogen has a lone pair like this, and here is a benzene ring. So this lone pair of electron is involved in resonance because they undergo resonance like this. It means this pair of electron that is present in p orbital. Moreover, this nitrogen is sp2 hybridized. Why it is sp2 hybridized? Because it is attached to sp2 hybridized carbon atom. So it has a lone pair, so it is sp2 hybridized. But its lone pair of electron is present in p. It means number 1, that is not a favorable site for protonation. Number 2. Now in case of number 2, we can see nitrogen ने पहले से ही p bond, p orbital अपना use कर लिया. It means this pair of electron that is present in sp2 hybridized orbital and is not involved in resonance. So here protonation can be possible. Nitrogen 3, again this nitrogen uses p orbital for फॉर्मेशन ऑफ दिस डबल बॉन्ड। तो इसने भी अपना p ऑर्बिटल यूज किया है। इट मीन इसका जो लोन पेयर है दैट इज आल्सो प्रेजेंट इन sp2 हाइब्रिडाइज्ड ऑर्बिटल, so easily available for protonation. 4 number, again this nitrogen uses its p orbital, so this pair of electron is present in sp2 hybridized orbital. 5-1, the nitrogen is now sp2 hybridized, so it is forming 3 single bond, means इसने अपने 3 sp2 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 hybridized orbital use कर लिए। So this pair of electron is present in p orbital. It means it get involved in resonance, so it will not donate electron for protonation. So now we can see in this molecule the nitrogen number 2, 3 and 4, they can easily donate electron for protonation. So your option B is the correct answer. Next question, number 2. These are the questions from JEE Main NEET. This is a very simple question. You can solve it with the help of hybridization concept if you know well. The order of basicity among the following is 4 compounds are given. Say number 1 is CH3 with a double bond having lone pair of electron, and here is NH2. Second compound given is a ring like this, nitrogen atom with a double bond, and here is again a nitrogen atom, and it is like this. Number 3 is a ring like this, so this nitrogen there is a double bond. And number 4 is H2N double bond, NH single bond, NH2. Every nitrogen which form a 3 bond that has obviously a lone pair of electron. So the options are A 4, 2, 3 and 1. Option B 2, 1, 4 and 3. Option C is 1, 4, 3 and 2. And last option is option 4, then 1, then 2 and then 3. So these are the options given. So this is true. So you have to find the order of basicity. Now basicity depends upon the tendency to lose electron. Obviously in all these 4 compounds nitrogen will lose electron. Now first of all, on the basis of hybridization we will see which nitrogen will donate pair of electron. Again come to the first molecule. This nitrogen is sp2 hybridized because it is attached with this sp2 hybridized carbon atom. So its lone pair is present in p orbital. So this lone pair is present in p orbital. But this nitrogen is also sp2 hybridized, but it's already used its p orbital. So this pair is present in sp2 hybridized orbital. It means this nitrogen gives lone pair of electron easily. Means this compound is basic due to the presence of this lone pair of electron, not this lone pair of electron. So in the second compound, This nitrogen use its p orbital, it means this pair is present in sp2 but this pair is present in p. It means this nitrogen is responsible for basicity. In 3 also, this pair is present in sp2 and this pair is present in p. Again, this S lone pair is responsible for basicity. And in last compound also, this pair and this pair, these are present in p orbital, but this pair is present in sp2. So first step is to find out which nitrogen will give electron easily. Second is, now we can compare. See the last one, this nitrogen donate electron like this nitrogen donate electron like this. So it increases electron density on NH. Now we compare it with this. It also increases electron density but less amount. So increases electron density but relatively lesser than 4. It means your 4 is more basic than 3. Sorry, 1. 4 is more basic than 1 is here. 4 is more basic than 1 is here. Here is also 4 is more basic. Here is also 4 is more basic. Then we have to move to compound number 2 and 3. So out of all these 4 compounds, only fourth compound is there in which the maximum electron density is there on the nitrogen, which is responsible for the basic nature. So obviously your number 4, that will be the most basic out of these 4, because in these 2 compounds you can see this lone pair is present in P, it shifts like this, and it increases its electron density a little bit. Moreover, this compound is aromatic. Here this compound is aromatic. Aromatic compounds are much more stable as compared to the other non-aromatic compounds. This compound is your non-aromatic. It also gives this lone pair of electron to this lone pair of electron. Non-aromatic are less stable than aromatic. This is sp3, 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 so that's why you say it non-aromatic. Except 3 all are non-aromatic. It means your compound number 3, that will be least basic. Compound number 3 least basic here and here. Compound number 4 most basic here. So overall your correct answer is option number 4. Now we will explain. 4th is most basic because in case of 4 compound, this nitrogen has maximum electron density because there are 2 electron donating groups. They donate electrons through resonance. And after that we have a number 3 because in this case also they give electron. This methyl also give electron due to inductor effect. But here the resonance effect is stable and more stronger than the inductor effect. That's why 4 is more basic than 3. Then come to 1 and 2. After the 4th compound, we have an option number 1 and then we have a 2. Why 2? Because 3 is aromatic in nature. In case of 2, we have, because this electron pair is responsible for basic nature and this carbon is sp3 hybridized. This carbon also gives electron through inductor effect. But here, this pair is responsible, this electron, this carbon and this carbon, they both are sp2 hybridized, and sp2 hybridized carbon is more electron active than sp3. So overall order, out of these 2, we can say that this compound number 3, that cannot give electron easily, because if we compare the electron density on this nitrogen and this nitrogen, here the electron density will be less. Moreover, it's an aromatic compound. So 3rd will be the least basic, then the 2nd, then the 1st, and most basic is the 4th one. Then we move to the next question. Question number 3, ये नीट का क्वेश्चन है. That's a easy question. The नीट 2013 में था ये. 2 क्वेश्चन हैं इसके. the radical दिया हुआ है, this benzyl radical is aromatic because it has four options are there. A is a 7p orbital and 7 unpaired electrons. Option B, 6p orbitals and 7 unpaired electrons. Option C, 6p orbital and 6 unpaired electrons. And option D, 7p orbital and 6 unpaired electrons. Now, very simple. Aromaticity is basically due to 6 pi electrons actually, because it fulfills the Huckel's rule. So here we have a 6 pi electron, here we have a 6 pi electron. Unpaired electron means which are present in p orbital. As every atom here, that is sp2 hybridized and one unhybridized p orbital is there. When you write the configuration like according to VPT, carbon has like 4 electrons in that cycle state. So when it forms sp2, so these are involved and this is an electron present in p orbital. This is unpaired. So here unpaired means present in p orbital, that get involved in the formation of your double bond. So this unpaired electron that get not involved in the ring, because the first condition for the compound to be aromatic is it should be cyclic. This carbon is not in the cycle, it is outside XO. So only 6 p orbitals are there for each p orbital like this on every one carbon atom. हर carbon के पास एक है, which are present in the ring only. We will not count this because this is not in the ring. The first condition, the compound will be aromatic, that it should be cyclic. So your correct answer is 6 p orbitals and 6 unpaired electrons. Next question is J 2018 का है. That is which of the following molecule is least resonance stabilized. 4 options are there. Number 1 is this. Number 2 is your benzene. बहुत easy question है. C option is your compound like this, and D option is compound like this. So now out of these 4 molecules, one is least stable, resonance stabilized. That can be least resonance उसकी stabilization जो है least है. कैसे पता चलेगा? हम देखेंगे कि out of all the 4 compounds, this carbon is sp2. All the other carbons, sorry, sp3. All the other carbons present or oxygen present in these molecules are sp2. So when it is sp3 hybridized, there is no carbon or other atom present in all these orbitals which is sp3 hybridized. Only option C has one carbon atom which is sp3. sp3 hybridized means इसके पास p orbital नहीं है. If there is no p orbital, it means resonance is not there. So your correct answer is C. So ये थे कुछ जेई में नीट के क्वेश्चन. नेक्स्ट जेई का क्वेश्चन एक और है. We will move next compound. question of J में question number क्या था 4 था 5 था say 5 1 2 3 4 5 okay which one is aromatic which one is aromatic in the following ये J मेन का क्वेश्चन है options are number 1 6-member ring with a 4-member ring. Number 2 option is a compound like this and we have 1 2 3 4 so 5 6 and 7 this is the option. So second option. Third option is your 5-member ring like this. So this 5-member ring has electron pair like this. And the last fourth option or B option is your compound like 7-member ring like this. So these are the options. Now we will see which one is aromatic in nature. So first one, there are two rings. So first ring is aromatic, second ring is non-aromatic. Aromatic plus non-aromatic, it becomes non-aromatic. Sorry, second one is anti-aromatic. So when we have aromatic and anti-aromatic, overall the compound is anti-aromatic. Second compound is a cyclic compound, is a perfect plane due to the presence of this double bond. If we remove this double bond, it may be out of plane because then it become aniline. So in this case, we have 1, 2, 3, 4, 5, 6 and 7 pi electrons. 7, you can say double bond. Or total 14 pi electrons. This double bond, the pi electron of this double bond get not involved in the resonance. So there is a periphery resonance of this molecule, and only the role of central double bond is to keep all the rings in one plane so that the compound get highest stability. So first condition is cyclic, second is planar. So to make such a big molecule in one plane, this double bond playing a role. It's not get involved in resonance, so we will not count it. So we have only 14 pi electron. 14 pi electron means it is aromatic, because it follow 4n plus 2 rule. Then the third one is we have overall all the carbon atoms are sp2 hybridized, but there are two rings. So this ring is anti-aromatic, this ring is also anti-aromatic. Overall compound is anti-aromatic. This is non-aromatic because this carbon is sp3 hybridized, so this is non-aromatic. So your correct answer is number 2. Number 2 compound is aromatic. Then we will move towards some questions of IIT JAM.